Hello, everybody. Welcome back to Easy Learn. And today's topic is the cosine rule. And before we jump on to what cosine rule is, we need to look back at the sine rule and discuss what important things it had. So, sine rule was used to find lengths and angles of a non-right angle triangle. And how did we know that in a particular question, how am I supposed to use the sine rule or probably some other rule? Then, if you had two lengths and two angles, then we would know that, okay, I'm going to be using sine rule for that. So it was important that when we're dealing with sine rule, we had two lengths and two angles. Now, one of them obviously had to be missing. Either two lengths are given to me, one angle is given, and one is unknown, or two angles are given, one length is given, and one of them is unknown. Doesn't matter what is known or what is unknown. The only thing that matters is that if you have two lengths and two angles, you're dealing with two lengths, two angles, you're going to be using the sine rule. And the sine rule had some formula that said sine capital A over small a equals sine capital B over small b. And if I have a particular triangle, let's say XYZ, how would I know which one I need to take as my capital A and which one I would take as my small a? Now, any angle that you pick up, for example, if I'm taking my capital X as my capital A, then the length that is right opposite to that becomes my small x, or I would put it in as the small a. So it would be sine capital X over small x. Similarly, if I have the capital Y, the length right opposite to that is my small y, and when I have my angle Z, so the length right opposite to the angle Z becomes my small z. Now, this is all about sine rule. Now, what is the difference between the sine rule and the cosine rule, and what is similar? So, for cosine rule and sine rule, the similarity is that both of them are used to find lengths and angles of a non-right angle triangle. The purpose for both of them is the same, but how would we decide which one should we use? Depending on how many lengths and how many angles are involved. So for sine rule, it was two lengths and two angles involved, and for cosine rule, it's three lengths and one angle should be involved, which means that out of the three lengths, two could be available to me and one could be missing and one angle would be available, or three lengths would be available to me, one angle would be missing. The point of using sine rule or cosine rule is that we are supposed to be either finding missing lengths or missing angles. Now, sine rule was kind of basic. You just use sine A over A equals sine B over B for everything. But in cosine rule, there is a slight change. In cosine rule, when you are finding an unknown length, the formula is something like this that says c squared equals a squared plus b squared minus 2 times a times b times cos c. This is applied when you are dealing with an unknown length and when you decide that, okay, I'm supposed to be using a cosine rule because there are three lengths involved and one angle involved, so let me just find out using the cosine rule. So for that, if you're finding the length, you'll use this formula. But what if I want to find the angle? Let's say three lengths are available to me and one of the angle is missing. So in that case, the formula is something like this: cos c equals a squared plus b squared minus c squared divided by 2 times a times b. Now, do not get confused. These are not two different formulas. It's kind of the same formula, but only the arrangement is different. And why is this mentioned as two formulas is just to make your life easier. Because when you're finding length, and let's say if I want to find the angle and I find the angle using the length formula itself, then in the end, you are obviously supposed to be doing some rearrangements so that you can find the angle. So instead of doing all the rearrangements and you taking things to the other side, turning positives into negatives, and probably something that's in multiplication, you take it to the other side, turns into division. So doing all of that haphazard would just end up in a wrong answer, or you might get confused, or you might miss some sign, some positive would turn into negative. So just to avoid all that confusions and the high possibility of making a mistake, it's just better that we kind of put forth these two formulas and you can just remember them, memorize them, just so that it's easier. If you want to find length, you can use the first formula. If you want to find the angle, you use the second formula, just so that you know. I'm going to be showing you how you could rearrange this. Like, for example, if this was the formula c square a square b squared and ab cos c, now if I tell you that find this angle, in order to find this angle, what happens is that because this whole thing is a negative 2ab cos c, let me just write this down. C squared equals a squared plus b squared minus 2ab cos c. Now, if I want to take this, because now I'm telling you to find this angle, so first thing I'm going to do is take this negative 2ab cos c to the other side and take this c squared to the other side. Let's suppose that c squared is available to me and cos c is unavailable. So I obviously need to find it, and for that I need to rearrange the whole thing. So this negative 2ab cos c goes to the other side, turns into positive. So 2ab cos c turns positive, comes here, and then I have a squared plus b squared. When c squared goes to the other side, because c squared is positive here, goes to the other side, turns into negative. Now once I have a squared plus b squared minus c squared, as I told you, I would need this cos c, which means everything attached with the cos c should be going to the other side. So 2ab goes to the other side. Now this 2ab is in multiplication with the cos c, so when it goes to the other side, it turns into division. So I have cos c equals a squared plus b squared minus c squared divided by 2 times a times b. So cos c is something like this, which is ultimately giving you this formula to find the angle cos c equals a squared plus b squared minus c squared divided by 2ab. Now, the point of all of this working was that just to tell you how this length formula is being rearranged to turn it into an angle formula. So when we're dealing with this, when we're solving an actual question, doing all of this process is going to be just hectic, and you might get confused, and probably this negative c would when you take it to the other side, maybe you turn it into a positive. Maybe this 2ab, you keep it as negative and there's a negative here, or anything. It could be anything. You could result in any kind of mistake that would turn your answer into a wrong one. So it's just better that we have two formulas, that is one for length and one for angle. Just memorize these and it's going to be fine. And how would I decide which one's my A, B, and C? So again, let's suppose I have a specific triangle XYZ. So similarly, how we used to be having it in sine rule, that if there is an angle, the let's say an angle x, the length that's right opposite to that is my small x, the length opposite to the angle y is my small y, and the length right opposite to the capital Z is my small z. So I'm going to fill it in this cosine rule as well. I'm going to be taking, because in cosine rule you just need one of the angles. So let's say if I want to find my angle x, so in place of my cos c, I will have my angle x, and in place of my negative c square, I'll be having the length that is right opposite to my capital X, which means that if this one is y plus z squared and this one's y and z, so this one, because x is unknown, so the length right opposite to that is my small x. The whole point is, do not get yourself confused with what is a, b, and c. A, b, and c are just letters. You could replace them with x, y, z, s, t, u, anything else. But the point is that whichever angle you're taking as a capital C, the length right opposite to that becomes your small c, and A and B would be the lengths that are available to you, the other two lengths. So you will understand this concept more clearly in the examples we're going to be doing. So let's suppose I have an example like this, XYZ, where my XZ is 14 centimeter, my ZY is 8 centimeter, and my angle Z is 56 degrees, and the length right opposite to 56 is K centimeter. Now, if you notice carefully, what are we doing in this? Now, as you can see, there are three lengths involved and one angle involved. Now, it doesn't matter if one of your angle is missing or one of the lengths is missing. The point is that the whole question is revolving around three lengths and one angle, which means I'm going to be using the cosine rule. Now, what am I supposed to be finding in this? Am I finding the length or am I finding the angle? Now, as you can see, that xy is k centimeter, which means I am trying to find my length. Now, if you have to find the length, the formula says c squared equals a squared plus b squared minus 2ab cos c, which means now if I replace my A, B's, and C's with the stuff I have. So as you can see, whatever angle you have, that will always come in the place of your capital C. And the small c is always going to be the length that is right opposite to your angle C. The capital C and the length right opposite to that becomes my small c, which means I'm finding my k. So I'm just going to be rewriting this stuff. So k squared equals the a square, which I could take either 14 or 8, whatever, it's completely your choice. So k squared equals 14 squared plus 8 squared minus 2 times 14 times 8 times cos of what? 56. Now, this is the stuff I need to write down on my calculator. Now, for that, you need to go on your scientific calculator where you will be writing down this stuff. So it was 14 squared, so I'm going to be writing 1 4, and then in order to put a square, as you can see, this is this x to the power of y thing there, so you'll just click that. So 14 squared, you'll have this box right there, and you can just put a 2 here, so it becomes 14 squared. Okay, one important thing in this is that you are supposed to be putting your stuff into brackets. It's just always good practice to put everything into brackets and then solve. So 14 squared plus, it was 8 squared, so 14 squared plus 8 squared, and then minus, and then again another bracket between the minus. So minus 2 times 14 times the 8 times cos. Here, as you can see on your scientific calculator, you have a cos function, and make sure your calculator is set on degrees. Right now it's on rad, but I'm going to be clicking degrees because I need my answers in degrees unless and until somebody asks for the answers in radians. So 14 squared plus 8 squared minus 2 times AB, that's 2 times 14 times 8 times cos 56. And when I do equals to that, it's 134.7. So going back on my thing, so I have 134.7 as my answer, which means that my k squared is equal to 134.7. Now, the thing is that you cannot have a 134.7 here. Why? Because I have a square attached with the k, which means that I still don't have my k exactly. It's just the value of my k squared. So in order to find my actual value or my k value, I would need to take the square to the other side. And now when you take your square to the other side, as discussed way before in our videos, that when a square goes to the other side, it turns into a square root. So if I have square root of 134.74, let me just write 7 4 there. It's just always better that while you're solving things, make sure that you keep your answers to 2 to 3 decimal places so that you can get a more accurate answer. The last answer, the final one, you can just round it up to maybe 1 decimal place or 3 significant figures. But when you're going ahead, you're solving it, so it's just better that you keep it to at least 2 3 decimal places. So when I do square root of 134.74, the square root sign on your calculator is right here. So square root of the answer, it gives me 11.607 and so on. So I could just write that my k is equal to 11.6 centimeter. So this is my answer. My k becomes 11.6. So xy, the length xy is 11.6. Again, keeping in mind that I was dealing with 3 lengths and 1 angle, and if I'm using the cosine rule, I have to first check that am I finding the angle or the length. If I'm finding the length, this is the formula I'm going to be using. And then you just work it out, put stuff on your calculator, make sure it is set on degrees, and then you'll get some specific answer. In the end, do not forget to take the square root. It is very important that you remember that in the end there is supposed to be a squaring part there. So just do not forget that and put square root of whatever answer you get, and that will give you the final length. Moving on, if I try to figure out another question, That involves the angle. Let's suppose my xz is 24 meters, my zy is 16 meters, and my xy is 20 meters. And if they're asking this one, angle z as k degrees. Now again, you have three lengths and one angle. Three lengths are available to me, one angle is missing. Again, I'm going to be using the cosine rule because it has three lengths and one angle, the cosine rule. Now that I have to find my angle, so the angle formula is slightly different. The formulas are the same, it's just a different arrangement. So to find the angle, I'm going to be using cos c equals a squared plus b squared minus c squared divided by 2ab. That means 2 times a times b. Now, what is my cos c? Now, c again is going to be the angle k. So I'm just going to write, let's suppose, cos k equals the a squared plus b squared minus c squared. A and b is not really important, but c definitely is. Now, which one's my c squared? The length that is right opposite to my capital C, or my angle, whichever angle that is, the length right opposite to that becomes my small c, which means this is supposed to be subtracted from the a squared and b squared. So I'm just going to be writing 24 squared plus 16 squared minus 20 squared divided by 2 times 24 times 16. Now, if I do that on my scientific calculator, now one very important thing is that in this particular question, it is a good idea that either you just do the numerator part separately, just do 24 squared plus 16 squared minus 20 squared first, and then divide by, in a bracket, just write 2 times 24 times 16 and then do it. Or if you just want to do it straight away in one go, it's just always a better idea, or more than a better idea, like if you do not put these brackets, you're supposed to be ending up in a wrong answer, because according to the order of operations, division happens first and then it's going to be the multiplication, then addition, and then subtraction. So the calculator is going to do it in that order if you do not set the boundaries. So, and obviously we don't want division first. In that case, it's going to be 20 squared divided by 2 first, and we don't want that. We want that 24, 16, and this negative 20, they're being squared and then added and subtracted first, and then they're being divided by 2 times 24 times 16. So in order for this to really work, we're going to be putting these brackets, and inside the bracket I have 24 squared plus 16 squared minus 20 squared, then put a division sign, and then another bracket open, and then 2 times 24 times 16 bracket close. So once I do all of that in my calculator, you're going to be getting some answer like this, 0.5625, which means cos k is equal to 0.5625. But obviously, this is not my angle. Why? Because there is another cos there. I don't want my cos k, I actually want my k. What is my k degrees? The value of my k. So for that, whatever is attached with the k goes to the other side, which means this cos goes to the other side. Now, when this goes to the other side, as also discussed in most of our previous videos, that when cos goes to the other side, it cosine or tan anything goes to the other side, it turns into cos inverse. So cos inverse of 0.5625. So again, put that up in your calculator. First thing, make sure your calculator is set on degrees. Second thing, because we're dealing with inverse on the scientific calculator, you will have this I and V. Once you click I and V, you have sine minus 1, cos minus 1, tan minus 1. So I'm going to be selecting the cos minus 1. When I do that, I'll have something like this, arc cos of 0.5625, which gives me 55.771 and so on. So I could just run it off to k equals 55.8 degrees, which means that this angle right here is 55.8. So this is how you go about. First of all, you have to figure out that we're dealing with three lengths and one angle. Secondly, you have to figure out what you have to find out, either the length or the angle. If it's the length is unknown, then you use the length formula. If the angle is unknown, you would be using this angle formula. Put it all up, set it up, and put it in your scientific calculator, and then figure out the answer. Make sure your calculator is set on degrees, and also make sure which one you're taking as your capital C, and whichever angle you're taking as your capital C, the length right opposite to that becomes your small c. So this is pretty much about the cosine rule. You just gotta be a bit careful when you're dealing with cosine rules and also sine rules. It's important that the lengths and angles that you're taking as your C, that's the most important. So that's pretty much it. If you have any questions, any confusions, you can drop them down in the comment section below. Thank you so much for watching Easy Learn, and like, share, and subscribe.